Today we're going to take a look at what I did to fix a problem on my 2003 Expedition where the engine would lose power and die while traveling down the road. And this was accompanied by a DTC of P0231, that's low voltage on the fuel pump monitor circuit. So let's take a quick look at how this code sits and what it means, and then I'll show you how I took the cheap route to repair it on my vehicle. On this vehicle, the fuel pump relay is located in the central junction box. Central junction box is the name they used for this model year. On some of the older vehicles, they used to call them GEMS, Generic Electronic Module. On a lot of the newer vehicles, they call it an SJB, Smart Junction Box. Basically, it's the interior fuse panel, but it's more than just a fuse panel because it actually has an integrated circuit board in it and can actually do some smart functions. Now, for whatever reason, Ford chose to solder this relay directly to the board of the central junction box rather than allowing it to be replaceable. So the only way to replace a fuel pump relay on these vehicles is to replace the central junction box. The primary side of the relay and the switch side of the relay both power up from the PCM relay, which is also contained internally in the central junction box. And the PCM relay turns on or provides power to the fuel pump relay anytime that the key is in the start or run position. The primary side of the relay is grounded or turned on by the PCM, or the powertrain control module. Anytime the key is cycled, the PCM turns on the fuel pump relay for 3 to 5 seconds. It's also grounded anytime the PCM sees the signal from the crankshaft position sensor or if the engine's turning. So anytime we cycle the key, the fuel pump is only going to run for 3 to 5 seconds unless the engine starts and is running. And if it is, then it will continue to run. So the switch side of the relay leaves the central junction box and goes to the inertia switch. If you're not familiar with an inertia switch, it's basically two contacts with a metal ball held against them by a magnet. The ball closes the gap between the two electrical contacts, thereby allowing electrical current to pass through it. The idea of the inertia switch was so if the vehicle was in a collision, it would get hit hard enough that the ball would drop and open up the circuit to the fuel pump, thereby the fuel pump wouldn't run. The thinking was if a line had been punctured or pierced in a collision, that way the engine wouldn't be sitting there running and the fuel pump wouldn't run and continue dumping fuel all over the ground. Now, an inertia switch does have a button on top that allows you to depress the magnet down into it and retrieve the ball if it ever is knocked off. It's literally a reset switch if the inertia switch is ever tripped. Now, from the inertia switch, the electrical current goes directly to the fuel pump. And then there's a second wire that comes out of the fuel pump and goes directly to ground. So where does our P0231 low voltage on the fuel pump monitor circuit code come from? Internally in the central junction box, there is a second circuit that is tied to the circuit that powers the fuel pump. Now this circuit comes out on a separate pin, separate electrical connector, and goes directly to the PCM. This allows the PCM to know anytime the fuel pump is powered up, or in this case when it's not powered up. And that is where our code P0231 low voltage on the fuel pump monitor circuit comes from. The circuit is literally called the FPM, the fuel pump monitor circuit. Now what has usually happened when you see this code is internally on the board in the central junction box where the fuel pump relay is soldered to the board. The soldering has started to corrode or degrade over time, and this has caused a little bit of resistance to build up on that soldered joint on the board. Once you start getting a little bit of resistance across the soldered joint, that builds up heat, which further softens or melts the solder, and then the resistance continues to get higher and worse. At that point, you usually get kind of a hot electrical smell in the vehicle, and the vehicle will either intermittently stop running, or it may just completely stop running. So let's take a look at what I did to fix this on my vehicle without replacing this central junction box. The central junction box is located on the passenger side behind the kick panel. The kick panel is the interior trim piece that would be to the right side of your feet when you're sitting on the passenger side. And there is a door on the front of it that you can remove to see the central junction box or if you need to replace a fuse. On this vehicle, we're going to have to remove the floor mat so we can get the door or the front cover off of it. Okay, and with the floor mat removed, we can then pull this panel out. And that right there is the central junction box or interior fuse panel. We're going to go ahead and pull the rest of the front kick panel so I can show you what I've done in there. We're going to have to pull this scuff plate off first though, since it's over the top of it. With the scuff plate removed, we can go ahead and pull up the weather strip that's over the kick panel. And that should allow us to get the kick panel out of there. With the kick panel removed, we can see behind it, and I can start to show you what I've done here. There's quite a few additional relays wired in on this vehicle, and in some upcoming videos I'm going to be showing you what I'm doing with those. Today we're just going to look at what I did with the fuel pump circuits to get around the central junction box failure. It looks like I was nice enough to label the relay so I would know which one it was if there was ever a problem with it in the future. I also labeled all 4 of the wires coming off of the relay as to what circuit they go to on the vehicle. In fact, before I wired this up on this vehicle, I sat down with the wiring schematic for quite a while and figured out exactly what circuits I needed to tie into and how, and then brought it over to the vehicle with them already labeled to find those circuits and tie it in. And we'll take a look at which circuits I tied into and on which connectors in just a minute. And normally for this kind of a thing, I just use a universal cube relay. If you've never used or wired a relay before, they've got the wiring schematic right on the top of the cover usually. And just like our wiring diagram we were looking at earlier, 85 and 86 are our primary windings. And then pin 30 is our power in for the switch side, and 87 is going to be the output we're going to be using for the power out. So if we unplug one and flip it over, so if you look at the bottom of the relay, all the pins that are coming out on the bottom are labeled with numbers that correspond to the diagram on top. Pins 85 and 86 are going to be our primary coil windings, and those are on opposite sides of the relay from each other and are both facing the same direction. Pin 30 is at the bottom and the number is in the shadow cast by its pin there. Pin 87 is at the top, and if you look, pin 30 and 87 are opposite sides of the cube also, but the pins are turned 90 degrees from each other. Now the pin in the middle is going to be 87A, and on this we're not going to use that for anything. And then we've got a matching pigtail. Now because all the pins aren't turned the same direction, it will only plug in one way. So let's start looking at how I wired around the central junction box and installed an external relay for the fuel pump. Let's look at our wiring schematic from earlier, and let's add an external relay. Let's start with the primary side of the relay. We're going to want to power the primary side of the relay off of something that turns off and on with the key, or even better, the PCM relay. The same 20 amp fuse that powers the fuel pump also has a circuit that tees off of it internally inside the central junction box and goes to power the mass airflow sensor. So if we splice into that, we'll still be powering the primary side of the relay off of the same power source. So let's look at where that wire and that connector are on the central junction box. We're looking for connector 270A. So if we go to the fuse box and then to the central junction box up above it, right there, the 12-pin connector at the very top left corner is the one we're looking for. So if we go ahead and unplug that, we're looking for pin 10. It's a red wire. It's on the same 20 amp fuse as the fuel pump, and it goes out and provides the power for the mass airflow sensor. Now it's a 12-pin connector, so pin 10 is 3 pins from the right here. And you can see where I spliced into this circuit right above there, the heat shrink. So the next circuit we're going to tie into is going to be the ground for the primary side of the relay. And that is a light blue wire with an orange stripe from the central junction box to the PCM. We're not going to want to splice into that one. We're going to want to actually cut that wire and then seal and heat shrink the wire from the central junction box and then tie into the wire from the PCM and tie it into our relay. The connector that we're looking for to tie into is connector 270B, and it's located down and to the right of the connector we tied into previously. Now the wire we're looking for on that connector is light blue with an orange tracer, and it's located at the very bottom right corner of the connector. You can see where it was cut off here and sealed with heat shrink. And then the wire that was cut off from that now goes to pin 86, the ground for the primary side of our new relay. Wiring the primary side of the relay this way is going to allow the fuel pump to operate exactly as it did from the factory. The next thing we're going to look at is the power for the switch side of our relay. Now I probably could have tied this into the red wire that I pulled the power for the primary side of the relay from, but my concern with that was I wasn't sure what kind of internal damage there was inside the central junction box, and I wasn't sure if this would work at the time. So I guess I thought by wiring it up to a separate power source, if there was an issue with it or if the vehicle died with the same problem, I could just jump it with a paper clip from pin 30 to pin 87 on the connector and then go ahead and drive home. I guess I should also add that it's been wired up and I've been driving it this way for over 5 years now with no problems. So on the left side of the central junction box is the main cable that is the power feed for the central junction box itself and all the fuses in it. I used a weatherproof fuse holder with a 20 amp fuse in it and crimped an eyelet on one end of it and then bolted that to the main power feed into the central junction box. From there it just goes over to pin 30, the main power feed for the switch side of our relay. The last circuit we're going to have to wire up is the power out of the switch side of our relay, and that's going to go to the fuel pump itself and power it, and it also needs to go to the PCM to get rid of our code for lack of power to the fuel pump. So that's two different wires or circuits with green and yellow wires that we need to cut off of the central junction box and splice onto pin 87 of our new relay. The first wire we're going to look for is in connector 270B again, and it's right next to the light blue with the orange stripe that we previously worked on for the primary side of our relay. Now this is going to be the dark green with the yellow stripe that goes to the PCM, so the PCM knows if the fuel pump is powered or not. We're going to need to cut that wire off and heat shrink the end that's on the central junction box to seal it, and then the other end, the actual wire, is going to need to go to pin 87 on our relay. The last wire that we're going to need to find is a green with a yellow stripe again, and it's located in connector 270K, and that is a 4-pin connector directly above 270B, the last connector we took a wire out of. Now the green wire with the yellow stripe is located in the lower left corner of connector 270K. You can see where it's been cut off and heat shrank to protect it here. I'm going to go ahead and pull that down so we can get a better look at it. Like I say, it's a 4-pin connector, and this connector is the one that actually goes to the fuel pump itself, the green and yellow wire there. So we've cut it off and heat shrank it, and then the wire itself, you can see it in the harness there where I've spliced onto it. But that green and yellow wire and the green and yellow wire that we previously took from connector 270B both go to pin 87, the power out, on the switch side of our relay. If you found this helpful, please click the like button down below. I'm trying to release new videos every Monday, so please subscribe. We got some more great stuff coming. And as always, have a great week.